We're going to try to do an application. Let's see if we can see how this could fit into what we've been doing. So let's just look at this problem just for what it is. So flying with the wind, a plane went 183 kilometers per hour. Flying into the wind, the plane only went 141 kilometers per hour. Find the speed of the plane in still air and find the speed of the wind. Okay. So as I read through that, I kind of pick up on the idea that there's this plane. That's where I'm trying to understand the problem. And this plane has got a tailwind, if you will. It's going with the wind, which we call a tailwind. And then it's got to fly back into that wind, which we would then call that like a headwind. So a tailwind would make you go faster. The headwind is going to slow you down. But what the question is asked us to do is find the speed of the plane in still air. In other words, as if there's no air at all blowing, slowing it down or speeding it up. What's the actual speed of the plane, if you will? And then we also want to know what's the speed of the wind. Again, notice it said it should be basically we're flying into the same wind as well. So flying with the wind, flying into the wind. So we have a tailwind and then a headwind. So we're looking for two things: the speed of the plane and the wind speed. So there's like two unknowns, if you will. We could use x and y, if you will. So we have the speed of the plane we don't know what that is, so we call that x. The speed of the wind we can call that y. There's two things that we're looking for in this problem. Now, one of the things I can do is just make up some numbers. I know that the plane speed has to be between these two numbers, so I might just pick a number that's halfway between those guys, kind of maybe like about a 155 or so. So let's suppose I said 155 was the speed of the plane. What would I have to add to that to get then that 183? So in other words, since I'm flying with the wind, that wind is going to help me go faster. So I'm going 155 plus, what would that be to get 183? Looks like that would be, is it 28? Yeah, 28. So 155 plus 20 would give me 183. Here's the catch though. Flying into the same wind, my plane only went 141 miles per hour. In other words, if I was going 155, let me put that in blue again. 155 minus then this 28, if you will, that would have to give me 141. I don't think that's happening. 155 take away 28. So I'm picking up on kind of borrow. They're gonna look like that's like 127. So it looks like my wind speed can't be quite that fast. So I'm going to probably have to bump this up a little bit more. So I may try maybe like 160, 165. Let's try 165. Let's see where that takes us. So if I say the wind or the plane is flying 165, what am I adding to that to get this 183? 165 plus what's going to give me 183? Is that going to be like 18? Yeah, that'd be 18, wouldn't it? Now the question is, 165 minus the wind speed has to get me back to that 141. So I got to do 165 minus 18. 165 minus 18. I'm not seeing 141 there. Let's see what we got here though. I'm getting 147. Well, that's pretty darn close. It looks like I'm a little bit too high though, so we may want to try maybe, I don't know, about 5 off. Let's maybe go maybe like 162. So if I go 162 plus 21, that does give me 183. Does 162 minus 21 give me 141? 162 minus 21, that does give me 141. So by trial and error, we can kind of pick up on that the wind speed is 162. I'm sorry, the speed of the plane is 162. The speed of the wind has to be 21. That would meet the conditions of this problem. So I don't have to use algebra to solve. I can just kind of play with it just with some numbers. So I would call that a trial and error method. But if we pick on the problem, we kind of pick up we're trying to satisfy 2 equations, aren't we? So what I can pick up on is, let me get this out of the way. But we did say 162 and 21 were our winners. That's my wind speed. That's my, I'm sorry, I keep saying that backwards. That's my plane speed and that's my wind speed. So 162 kilometers per hour and 21 kilometers per hour would be those 2 things. What I'm picking up about doing trial and error, the trial and error actually shows me a pathway to the equation. Notice how I kind of got the speed of the plane is x, the speed of the wind is y. I can write the equation x plus y is equal to 183. So I actually can write that equation as is, using our unknowns. Notice I got 155 minus 28. I can also go x minus y. The speed of the plane minus the airspeed is going to give me 141. So what I can create are 2 linear equations. And what jumps out at me is if I add these together with the elimination method, the y's are actually going to eliminate. So I think that the elimination method is a very good tool for this, because then I can kind of see that 2x, this zeroes out, and that's going to become, what's that going to be, 324? Yeah, I think 324. Then I have to divide by 2. So 2 into 324. I like dividing by 2 this way. Half of 300 is 150. Half of 20 is 10. Half of 4 is 2. There's my 162. So I get 162. Hey, that's what we got for x, wasn't it? Now to find what y is, we substitute the 162 back into one of these equations. So I put 162 plus y is equal to 183. And I can now solve, since I substitute x in for 162 in for x, I can now solve for y by using my 0 pair. So y is going to equal then, that's going to be 21. So, to clarify this, the plane is going 162 kilometers per hour, and the air is going to be 21 kilometers per hour. So make sure you clearly spell that out, which is which. So you may want to not just say x and y, but put the word plane and air into that. So that shows you that applications can be solved by using systems of equations. We're going to try to do one more application. Let's see where that takes us.